Hey guys, welcome back to another episode of Simuleos. Today is going to be an absolutely fantastic day, pretty sure. Obviously I have no way to verify that, but I'm pretty sure. You know, why not? Okay, so here's the thing, guys. I was in China the past week, and I realized, I wasn't able to stream. Well, yeah, sure, of course I wasn't able to stream. The Wi-Fi was actually quite bad, too. I wasn't really able to connect to anything, so I wasn't really even able to read email or anything. It was quite a pain, honestly, but that's okay. I did enjoy the time there. It was good. Hey, happy little rat. It was fun. We have a picture of our entire group from the conference beneath a giant statue of Mao Zedong, so that's interesting. Never thought I'd take a picture under him. And yeah, that's about it. So there's a whole bunch of other things that happened while I was there that I don't really want to get into, and let's see, the conference was good. But while I was there, I read like 20 papers because I had nothing else to do. Normally I'll like write pseudocode or just hop on my computer and try to write up some sort of simple algorithm or something like that, but I didn't really have the time to do that. So I ended up just reading papers in between talks. And of the papers I read one about an epidemic algorithm. Now, the epidemic algorithm is basically a way in which a virus will spread to multiple people, right? So I was thinking about it, and one of my friends once said that there should be a way to simulate a viral video, like how a video becomes viral, by simply using the epidemic algorithm, right? So I kind of got to thinking about how that would work, and I thought it'd be kind of neat just to test out a couple of things, because epidemic algorithms are, in essence, pretty simple. And we could probably use the epidemic algorithm to kind of model what a viral video will do depending on who shares it and stuff like that. So I wrote down the notes. Let me grab them real quick. Okay, here they are. And let's see what it's going to be. Hey, 11 Kazoos, what's up? So, yes, let's see how this goes. On the one hand, it could be fantastic. On the other hand, it could be awful. I think I even wrote down in the description exactly that. So we'll see what happens. Here's what I've got. And guys, this is one of the many times while I'm kind of coming up with things that I would like feedback, you know? The way I want to kind of present this when I make a YouTube video about it is rather than saying this is my current thoughts on the matter, I'd rather say I'd rather ask the question. You see what I'm saying? So I want to start out by just asking the question and then explaining my thoughts, you know? So that people have the ability to answer in their own way. They could say, hey, I realize this is your answer, but my answer is this one. And then they can give their own, probably better answers than mine. So I kind of like the idea that maybe in some sense, flood algorithms, yeah, so in some sense the visualization here will look a lot like that. I haven't quite figured out the best way to do it. But yeah, so I kind of have the idea. One second. I have the idea. I think, yeah, they're both basically the same in this case. Anyway, the point is, I have this idea where, like, we can get people to think about interesting problems by simply broaching the subject in, like, a YouTube video and then saying, hey, I don't really have a good answer to this, but I'm willing to hear your thoughts, you know? It's got to be questions that people are interested in answering, and even if they have actual answers, like even if there is a real answer to these questions that we ask, that's not really the spirit of the video, right? The spirit of the video is to figure it out, not necessarily to, look at other people's solution, And so that's kind of where we're going here. Hey, Cornick, what's up? Okay, so let's go ahead and get started by opening up Zernal. That was not Zernal. Did I open up two terminals? I sure did. And let's open up Zernal. And let's go ahead and get started. So again, it's been a little while. Forgive me if I'm a little bit rusty, but I think we can go ahead and get everything done we need to get done. Okay, so first of all, what is an epidemic algorithm? Let me describe it in kind of a naive way, because of course I've never implemented one on my own, so this is going to be kind of a little rough, but it should be okay. So an epidemic algorithm. Okay. Now, of course, there are people in chat who have done this before, right? So, there are always smarter people than me in chat. Just no matter what, there's always going to be someone smarter than I am. Or at least someone who appears smarter than I am. An epidemic algorithm basically is a model of how we'll say biological system infects, let's say, entities. Now, these entities could be anything. Could be humans, could be birds, could be trees, I suppose. So this is a good model for a number of different things. You know, like let's say we have a whole bunch of people. They're all moving around. They all have contact with certain people. Then they can transmit a virus to different people, right? Okay, so now we have the model of the biological system. One thing to note is this is also a rumor mongering algorithm. So this means that basically the same algorithm that we use to model the movement of a virus across a population is the same as the model we use to model the movement of information along a system. So just keep that in mind as we're going forward. Now, let's talk about viral videos. Okay, so viral videos. What exactly is a viral video? Well, I don't really have a good definition on my own, but if you Google viral video, this will escalate to full society simulation. It will stay sane. Nobody knows. So let me see. No, I don't want top viral videos. Here's what I want. Viral video is a video that becomes popular through a viral process of internet sharing, typically through sharing websites, social media, and email. So sharing, right here, this word sharing, is absolutely essential to making a video viral, right? This means, in my opinion, a viral video is something that you'll see in one social media platform, and then you'll see again in like 3 or 4 other social media platforms. That's what makes it viral, the fact that it is shared a lot. So the sharing is super important, okay? But my argument is it's not only the sharing, but also the pulling from YouTube. So a viral process is, let me see, objects and patterns that are able to replicate themselves and convert other objects into copies of themselves when the objects are exposed to them. So I believe, unless I'm completely off my rocker here, that this is basically the heart of the epidemic algorithm that we're talking about. So in this way, we should be able to model the viral video off of the epidemic algorithm. Now, the question is, how exactly does this viral video relate to, and this is my symbol for relate to, forgive me there, relate to epidemic algorithms. Okay, now this is where things get a little bit interesting. This is where I kind of put a little bit of thought into it. Okay, here's what I'm assuming. I'm assuming that there is one big global site that people use to pull videos from. So we'll call this video sharing service. YouTube is what people typically use, but we'll just say it's a video sharing service. Now, we'll say that this is connected to hundreds of millions of different people. Here I'm drawing 5. Okay? Now, all of these people will watch the video, and they have multiple different responses. They could simply watch the video and thereby do nothing. They could like the video. They could share the video. Or they could dislike the video. And this guy down here, I'm just going to erase. So, they could do nothing, they could like, share, or dislike. Okay, so what is happening in these 3 cases? Well, the one interesting case is share. In this case, we're doing something very different than the other ones. With the case of sharing, you're actually pushing the video onto a set number of people. So you're saying we have a network of, let's say, so YouTube has millions of people, but you have a small network of hundreds of people. Every time you share, you push the video onto that small network such that they watch it again, or for the first time. They could do anything, including die watching the video. Yeah, sure. But I think that'd be kind of a rare case, right? Now, in the case of nothing like or dislike, all 3 of these guys do something a little bit different, right? So rather than explicitly forcing people to watch the next video, these guys all interact. These guys all interact with how future video watchers, oh gosh, Oh gosh, future video watchers. Poll videos from the video sharing service. Okay, so here's where things get interesting. I'm using some very particular vernacular, some very particular jargon here, and that jargon is push and pull. Okay, we have basically two different epidemic algorithms that we need to discuss here. Now, one thing I have to point out is there are plenty of different epidemic algorithms. In fact, let me just go ahead and give you a link to the paper I read on the different algorithms, such that you guys are not out of the loop here. It's a pretty good paper. I think it goes through everything you need to know. Let me just very quickly pull it out and Google it for you. 1 second. Okay, paper is... Oh, it's just called Topic 9 Epidemic Algorithms. Fantastic. Okay, so I think it's this one right here. Come on, load, load, load. And then we should be good. Yep, this is it. Okay, so this is a paper I kind of read through. It goes through everything you need to know. Some of it may not be organized in the best way, but that's okay. It's also relatively straightforward to read and describes most of the methods I could think of, or rather, I couldn't think of any others, but then again, this is the first time I've really looked into this stuff in detail. So anyway, we have the push algorithms and the pull algorithms. Okay, so what is the difference here? The push algorithms are push algorithms. The push people, the people who push videos onto others. These guys force others to share or see information. Now the poll guys are a little bit different. These guys go to people in their network. People in their network. And ask. So the one way I always think about this is it's kind of like some guy going up to you and be like, hey, hear any good rumors lately? Or, you know, like what you used to do in high school when you wanted to know something about someone but you didn't want to ask the person directly, you would somehow get the information from someone else. That's kind of what we're doing here, right? So the push is basically some guy running around the high school being like, oh my gosh, Janice from, I don't know, gym class ate my shoe. And then the poll guys would be the guys who didn't hear this guy running down the hall, and they'd be going around asking everyone, hey, did you hear what happened to Janice? And then everyone would be like, oh, she ate some guy's shoe. Okay, that might have been a weird example, but point is, we have push and pull, and these guys influence how the information is propagated through the network. What this means is our algorithm is some sort of mixture between push and pull. However, it's not a standard push and pull algorithm, because the pull is always coming from YouTube. More than likely, you don't go to your friends and ask, hey, man, have you seen any good videos lately? Usually you'll be like, don't show me that YouTube video, I don't want to watch it. So they're always going to be pushing videos onto you, but you're probably never going to be pulling videos from them. One person that you do always pull videos from is YouTube. So here's what I'm going to say for YouTube, and again, this is where I kind of got creative with how I wanted to do this. Let me move this paper over here. Okay, so I came up with this idea of affinities with different people, and maybe this is right, maybe this is not right. This is where I kind of got creative. Okay, so here's what I'm going to say. Every person, let's go ahead and get started with the algorithm itself. So every person will pull a video from YouTube, our video sharing service, every time step, okay? Every time step, new video, okay? He then has his 4 options. He can then do nothing. He can like, he can share, or he can dislike. Okay, these are his 4 options. Or she. This is its 4 options. Okay, so these are the 4 options. Okay? What's your favorite film? Top 5? I haven't seen a movie in a very long time. I'll have to get back to you on that one. I will say that Grave of the Fireflies is definitely one of them. But I don't know I can't think of any of the others at this point. Let me think. Oh, there are some really good ones. Pixar films are pretty good. Yeah, I can't think of them off the top of my head. But I would probably say Grave of the Fireflies is definitely on that list. And then we also have probably a couple Pixar films in there. Like, I don't know, I really enjoyed... oh gosh, I don't know. I can't answer this question right now. Like, if you ask me like top 5 favorite cartoons, I can give you like my top 5 favorite cartoons, I think. But I don't think give you too many movies. I don't really watch too many movies. So, okay. So let's see. Do nothing, share, dislike, or like. These are the 4 options. Now, every person will pull a video from the video sharing service every time step. And this is what they'll do. Now, if they choose to share, the next time step, a certain random number of people will watch the video next time step. Now, if they choose to do nothing, like, or dislike, you want the music to turn down a little bit? Yeah, I guess we can do that. Okay, 1 second. But I think it's usually this loud, right? Is anyone... I guess I'll drop it a little bit, but it's usually that loud. I don't think I need to turn it down that much. Okay, so let me see. If they do nothing, share, or dislike, this is where things get a little bit interesting. So what does YouTube do on YouTube's side? 1 second, page, new page before. So what's the video sharing service do? The video sharing service basically has the job to provide videos to people. Okay, so then the people... 1 second. Okay, I might drop it a little bit more then. Should be something like maybe here? I'm not sure, I'm kind of just guessing. People pick from those videos. Okay, and we'll say it's a random pick. So YouTube will give you 10 videos to watch, and you pick at random from those 10 videos on the side. As far as favorite cartoons are concerned, Phineas and Ferb is definitely up there as probably my number 1, followed by Steven Universe, probably. I really like Steven Universe. Then Kim Possible is definitely up there. Danny Phantom, up there too. As far as the 5th slot, there's like a heck of a lot of other cartoons I enjoy watching. So I don't really think I can really put this slot in appropriately, but if anime counts... Oh, you know what? Probably I'll put like either Archer or Rick and Morty in that slot, honestly. I like both of those about equally the same. And maybe in those slots there's some movement here and there. But definitely Phineas and Ferb is my number 1 favorite cartoon. The other ones are kind of in there. Okay, so people pick from these videos. Now the question is, how does a video sharing site know which videos to give you? Okay, so this chooses videos based on affinity. Okay, what do I mean by this? I mean that every single person, when they watch a video, is somehow related to all the other people watching the same video. So if you watch a video on cats or whatever, then you'll be put into this network of everyone else who has watched that video about cats. Okay? So this means that if you guys all watch the same videos, then you'll have a 100% affinity if you watch the exact same videos as everyone else. It is this one. 1 second. 1 second. And verb. Let me make sure I spelled that right. Yeah, Phineas and Ferb. This one right here. Okay, good. So let's see. How does this affinity relate? So let's say your affinity with someone else is going to be equal to the number of videos you've seen in common. Over, let me see, total videos seen. Okay, so this means that your affinity will be some sort of percentage, right? So you could have 100% affinity with one person and 0% affinity with another person. 100% being if you've seen all the same videos, 0% if you've seen none of the same videos. Then we basically search all the closest people in affinity, all the people who are closest to you, closest to 100%, and we choose a video that basically matches with what other people have seen. So all the videos are assigned some sort of value. We'll call it video val. And this is going to be equal to a sum of I equals 0 to n, where n is the maximum number of people in the group. And it's going to be the affinity times some sort of like parameter. And we'll say affinity I, like parameter of I, times a delta function of I. Okay, what does this mean? It basically means we're going through, and if the person has seen the same video, then this guy is going to be a 1. Okay, so we'll say this guy's going to be a 1. Okay, if they liked the video, this guy is going to be a 2. So let's see, I think like was this one. If they did nothing, this is going to be this is 1. And if they disliked the video, it's going to be a, 1 second. It's going to be a 0. Okay, so I think this needs to be 1 here, something like that. No, maybe I was right, maybe before. It was blue. Just by this, this is a very fun project. We'll catch up with streams later. Okay, sounds good. See you around. Thanks for coming in though. So this means that there are two potential ways that a video, that watching a video will not at all influence the videos YouTube provides to other people. And that's if the like parameter is 0 or if they haven't seen the video at all. Finally, it's related to the affinity here, which is of course defined above. So it's also related to the affinity here. So in this way, 1 second, we can somehow approximate which videos YouTube will pull up simply by creating this list. Now, obviously, we don't have to sum all of the people. We can do some sort of cutoff, but at the same time, we have pretty much a good idea of which videos YouTube is going to show based on these three parameters, I think. And this is kind of what I want to try. Hey, Miriam, what's up? Okay, so this is kind of the idea. At this point, we can probably go forward with the actual programming, but I'm going to take a quick sip of water before getting started, and then we'll get started from there. I apologize again, we started like 5 minutes late simply because I couldn't get the stream quite working. I was trying a whole bunch of parameters on my side for some reason because again, every once in a while the stream will flicker and stuff like that. So I tried creating a test account and sending my information to a test account. However, the test account didn't have, how am I going to put this? Did not have quality settings. So because it didn't have quality settings, there's no way I can test whether the blinking is happening there or not, because it only happens when the quality settings are below source. So again, if you guys are seeing blinking, feel free to put the video on source because you shouldn't see the streaming or see the flickering there. And of course you can see me doing that right here at 5 o'clock. The stream's not starting, yada yada. Okay, I'm gonna get a quick sip of water, then we can go ahead and get started. I'm super scattered today. We'll see how far we get. Also, like, I always lose weight when I travel, even though I eat, like, I do everything I can to eat the same amount that I eat when I'm at home, you know, when I travel. But for some reason, I always lose weight. You know, no matter what I do, it's always losing weight. And so I lost like 2 kilograms when I was in China for the week, and I feel kind of bad about it. because like I just wasn't hungry, you know? It's not that I don't like Chinese food. Chinese food is great. It's just I didn't eat anything. And I feel bad, but that's okay. So let me go ahead and cd into the appropriate directory, cd projects and Simuleos. And I'm going to do the same thing over cd projects. Oh, actually, let's go ahead and make the directory first. Make directory, what are we going to call it? Let's call it viral video. Okay, let's go ahead and cd over here too. Cd projects, Simuleos, and viral video. Cd viral video. Oh. One thing I have to do about the visualizations, guys. I've been giving a lot of thought into it. My original idea with the visualization was that I would continually update the Cairo package that I have been using to create all the visualizations as I go along, you know? Because of that, I've been recopying the Cairo code into each individual directory. I think what I've decided to do is, rather than copying it into a whole bunch of different directories, is keep it in one central directory. Now, the reason I haven't been doing this before is somewhat obvious. It's because the code itself changes so drastically between every single iteration that I would end up breaking previous code. So I've just got to kind of finally settle with what the I've got to finally settle with how I want the library to work. And I think I'm going to start doing that probably later on this week so that I don't have to continually recode things, which should be a little bit more dynamic for you guys. It should be more interesting for everyone, I think. Hopefully. We'll see how that goes. Anyway, we're in the viral video directory. Let me go ahead and ls. Absolutely nothing here. And let's go ahead and open up a file. So we're going to viral video.cpp. Okay, so again, we're going to be using C++ for this project. We could use any language. I just chose C++ because it's one of the easier languages to read. I could have chosen Julia or something like that, which in some sense has an easier syntax. But again, people have been complaining that when I use Julia, it's kind of hard to follow. And since most of you guys know me for using C++, I'm just going to use C++ for this simulation. It shouldn't require anything that we can't do in C++. Rather, it shouldn't require anything that requires additional libraries in C++ to do. So we'll see how far we get. So let me go ahead and get started. 1 second, I think I already screwed up. Yep, that's right. Okay, so we're going to do viral video.cpp. And we're going to go from there. So, let's go down here. Purpose. Oh, come on, purpose. Oh, there's an R in there somewhere. There we go. To simulate how a video becomes viral. Okay, so let's go down here. I don't think I have any notes at this point, so we should be good to go. No, I'm going to do the same thing I always do, which is going to split up the code into 3 sections. The first section, I'm going to put all my includes and everything else, such as template, not templates, but such as, well, I guess templates, but function tags, you know, structs, things like this. Reason I do this is so that later on, if I write a header file, I can very easily just grab the top of the file, throw it into a header file without having to rewrite anything. It's kind of useful in that way. Okay, then of course I split it up with a main. I always like to have main separated a little bit with a bit of a partition. Just, again, it's kind of nice for me. Then at the end, I always write down subroutines. Again, these are actually functions, not subroutines, but I put them there because that's just where they are in the code. So let's do this. Put something in here. And of course, guys, if you have any questions, comments, concerns, feel free to let me know. And I will answer those as soon as I see them in chat. Subroutine. There we go. Gosh, I'm super out of it today. This is gonna be fun. Okay, so let's go here. So for main, obviously we just do what we always do, which is int main, and there. Nothing in there so far. So as far as structs and things like that, what do we need? Well, we definitely need a couple of different guys here. So we need a struct for every person. Hey, Arcare. So we'll do struct, and we'll call it human, maybe? But then that's not quite right, because there are definitely non-human watchers of YouTube. So let's see, struct, watcher. Okay. What else do we need? Do we need a struct for videos? I wonder. We might not. We might just be able to get away with calling the videos just some sort of list of ints or something like this. That might work okay. Okay, so let's go through and let's label what we need. So we have some sort of struct for all the watchers. Oh, viewer. Come on, viewer makes more sense. That's totally something, a word that people use all the time. Viewer. Okay, so we have struct for the viewer. Let's see. So in this, we're gonna have to have a number of different functions and things like that. But let's just go ahead and put life into the skeleton. First thing we're gonna need. Let's see. We're gonna want a vector of ints. So let's do vector, and let's go up here and include vector. And let's go down here, std. And we're going to say vector of, let's see. We could do ints. How do we want to represent the videos? I think the best way is to go ahead and just call all the videos ints. And I'll leave a note about that. Videos scene. Okay. Let me go up here and let's just go ahead and leave some notes. Video scene. One second. Videos will be represented as integers. Simply because their name. I guess it's obvious why they're integers, right? I mean, we don't care about their name. Videos, let's not put will be, we'll just put videos represented as integers. We don't care about their name. Okay, so how about we say videos, video ID, something like that. So this should be okay. So we have a vector of int for videos seen. Now, obviously they need a little bit more than that, right? So they obviously have the ability to like, dislike, share, or watch, which will all be on a particular integer. Now we have to think of this real quick. We also need another guy, which is going to be affinity. So we need an std vector of double, and this will be affinity. Okay, so we're getting there, right? So we have the video scene, we have the affinity, and obviously as we write this code, we're going to see a number of different functions that we're going to need as we go through. Okay, so we have the struct viewer. They have a list of videos that they have seen and the affinities. My question is, do they necessarily need anything else? We'll see as we go along. So, what do we need? Let me go ahead and put a comment in here. So, struct to hold all information for each individual viewer. Okay, let's go down here. And now we're going to say function. And what do we want in the function? The function is going to be to initialize all the people. The simulation. Okay, so we're going to call it, what should it return? I suppose it should return a vector of viewers, right? So we'll do std. Are you keeping history for viewers? Yes, that's kind of the idea, right? So, depending, yeah, it's basically that, history for the viewers. I was thinking about cutting it off at some point, such that, you know, we only check the last 10 or so videos seen, or something like this, but it depends on how the algorithm works. If it ends up working quite well, without that limitation, then we don't have to do that later. And let me go ahead and leave a note about that. Let's say video scene will hold history of videos, history for the viewer. Note, we may cut this off. Okay, good. So now we're going to want to return an std vector of viewers. Okay. Oh, why did I put plural there? And what are we going to call this vector? Doesn't really matter. So we're going to do init, I guess, viewers. Should be okay. What are we going to need? We're going to need int viewer number. It's going to be total number of viewers in the simulation. Okay, what else do we need? We need that. We will kind of randomly assign the affinities as we go along, so that should be okay. Now, what else do we need? Video scene. I guess we could start with the number of videos seen already. Yeah, okay, we could do that. Yeah, we could assume that every person at the start of the simulation already has 10 videos watched or something like this, which would then create our affinity. So let's do that. Let's say number int num videos. Okay. That should be okay. So let me go ahead and do this. Just run over here and let me run g++. Viralvideo.cpp. Of course, there aren't any problems. Just checking. And let's go ahead and initialize these people. So let's grab this function and put it down at the bottom. Okay, let's grab this. Oh, what am I doing with my life? I don't know anymore. Okay, let's grab this. Oh, what? Do I have caps lock on? Ah, crap, I have caps lock on. That would explain it. Okay, so what are we going to do here? Well, we're going to need some sort of random distribution that we're going to pull from. And we also have to think about something else here. We have to think about... What do we have to think about? We have to think about how many videos we have coming in. So the idea here is that we have maybe 100 videos coming in. And we have a viewer number of, let's say, 100 or so. I don't know, I'm making up random numbers. So if we have 100 random videos, what we'll do is we'll assume that every person has seen, let's say, 10 videos at the start of the simulation. So let me go up here. Viewers have seen, let's say, 10 videos at the start of the simulation. Okay. Oh, guys, I was thinking about it the other day. Here's what I was thinking about. Would you guys be interested if I started doing some videos again where I just randomly talk about something? I used to have this video series on YouTube where I would just randomly ramble about things, and that was it. That was the whole point of the video, just me talking about something, some thought that I had. I'd maybe write down some notes, but I definitely wouldn't fully plan the video out, you know? And I was thinking about doing some videos like this about, you know, like the utility in simulations and things like that. Recently I had a discussion with my advisor, who is a physicist, about the usefulness in simulations themselves. And, I don't know, I feel like there is a lot of utility in learning how to program, especially for scientific purposes. But I feel like not everyone fully agrees with me there. And I thought it'd be interesting just to kind of hear people's thoughts on different things. The problem is, I don't know, when it comes to YouTube, it's hard to create discussion, you know? It always ends up being that rather than creating discussion, I'll just say something and then people will be like, oh, cool video. And I'm like, thanks. And that's it, you know? It'd be super nice if I could somehow just really get people talking, you know? Asking questions, you know, learning things for themselves. That's kind of the hope. I just don't know how to do that yet. Okay, anyway, I'm kind of on a side topic. Question was, do you guys think I should try to further discussion, I suppose, on YouTube, or if I should just leave that for Twitch? Because you guys are usually quite good about talking to me about different things on Twitch. Okay, so now how are we going to init these viewers? Well, we of course need some random numbers, and I have to apologize. I always, every single time, forget how to initialize random numbers. I don't know why. Just every single time I do. So let's look at some previous code that we've been into. Ants, archive, Barnes Hut, Bastrop, none of these are important. FFT, function integrate, geometrical optics, Huffman. Oh, what am I looking for? Orbit. What was the last thing we did? What was the very last thing we did? Kuromoto. There we go. Man, I've disabled comments on YouTube. I always love a good talk rant. You see, do random. Okay, cool. So it might be something I try to do a little bit more. The issue is just that all of the simulations I do take a while for me to do. I mean, you guys know that because you watch me as I'm doing it. You know, sometimes it'll take me 2 weeks to get something out. And that's, you know, assuming I have appropriate planning. For example, Galaxy Simulation. I spent forever on my Galaxy Simulator, and we just didn't end up making a video about it. Huffman encoding was the same way. We have some really cool visualizations with the Huffman encoding, but I haven't yet put that into a video, you know? So, I don't know, there's certain things in there that definitely could use some, how do I put this? I could definitely I could put into YouTube videos, and I could definitely put out videos a little bit more quickly. It's just when I'm not happy with the quality of the video, I don't put it out, you know? That's kind of the idea, you know? I only want to put out videos that I'm happy with. Which is completely different than my previous mentality about YouTube, where I used to say that quantity was more important than quality. Basically, there's a video maker out there called CGP Grey. One second. I'm pretty sure a lot of people have heard of him. In fact, I think most people have heard of him because he's quite popular. But yeah, he basically puts out a video every month or something like that. But he's still, every one of his videos is very good. You know, everyone wants to watch the videos. So, okay, let me go ahead and open up a file here. I'm sorry, I keep randomly rambling. Let me go back here to Chromoto. And let's see, what do we have here? We have all the different files. We have optics visualization. I think it's how to dance.cpp. CPP. Okay. So let's go down to random here, and let's do it. Okay, so now we have to define random distribution. Gray doesn't follow people and just makes a video. What do you mean by that? So I do, maybe Gray doesn't follow people, that's fine. But there is something nice about how Gray does things. And that's that he's basically completely anonymous, you know? I don't know what it is, but recently I've been realizing that, I don't really like people in real life coming to me and how do I put this? Like, talking to me about my videos. I get it, it's kind of neat, and if they're close friends, it's fine, but it's weird. Yeah, maybe. It's weird to me when people just, you know, they walk up to me and they're like, I really like your videos or something. It just, I don't know, it strikes me as odd, you know? And I kind of like the fact that Gray is anonymous. I would like it to be that, you know, sure, people can know my face just fine, but I don't like the idea that they become so comfortable with it that they can just spot me in a street, you know? Because that's a little weird to me. Anyway, creating random distribution for videos seen by people. Okay? People's plural should not have been. Okay, so how are we going to do this random distribution? Let's just go ahead and do it this way. Static, std, random device. And this means we're going to have to read in random. So, one thing about Brady, though, Brady does a heck of a lot of different videos. I mean, he does basically all the videos in Nottingham, right? So then we're going to do static SCD, Merlin Twister, 19937, Gen RD. Okay. But actually, Nottingham recently unveiled a post doc, which was about the 60 Symbols YouTube channel. And I was really thinking about when I finish at OIS just applying to that postdoc, because I don't know, I think it's kind of neat, you know? It's the first postdoc I've ever seen, I think maybe the first postdoc ever, that is tied to a big YouTube channel. And the idea is that you spend, you know, I guess 80% of your time doing research, and then 20% of your time focusing on the 60 Symbols YouTube channel. I thought to myself, well, this is something I could probably do quite well, you know? I'm pretty good at doing that stuff. Doctor of Letter title? Doctor of Letters? Wait, what is a Doctor of Letters? I'm not actually sure. Let me go ahead and look up uniform int distribution. That's what I want, C++. Uniform int distribution. I believe it's just uniform int distribution int, and that's all we need. Yep, that's exactly what I want. So we'll say uniform int distribution. So we'll say std uniform int distribution, and we're going to say it is of ints. And what are we going to call it? I guess we'll call it, let me see, uniform int distribution. I guess we'll call it video scene, or rather chosen videos, maybe something like this. And we'll say it's from, because these are unique IDs, I'm going to want to go from 1 to num videos. And this should be okay. And I think that's what we need there. Yep, just 1. Okay. Now, one thing I want to point out, the video that we are going to be making is going to be video 0. So let me go ahead and leave that as a not here. You can see it later. I'll take a look at that. Something to watch over breakfast. Doctor of Letters. Oh, neat. Alright, let me go down here. 1 second. And let's say the video we're propagating is, let's say, video 0. Just to keep track of it a little bit easier. Okay. So this is going to be from 1 to number of videos, and that should be okay. So now what we have to do is use this correctly. So what are we going to do? We're going to initialize all of the viewers. So let's go ahead and create our vector of viewers. So we're going to say std vector viewer. 1 second. And what are we going to call it? I guess we could call it viewers plural. Yep, that's what we're doing. Okay, so the viewers plural. So I guess the first thing we need to initialize is their video scene list, and then we have to find their affinities. I think that'll do it. Okay, so what are we going to do? I guess we're going to say viewer number. And let's go ahead and down here, return viewers. Okay, good. Now up here, we're going to say for int I equals 0, I less than viewers, dot size. Then we're going to do I plus plus. Now, obviously, there is a more efficient way to do this. Let me think. Let's see, so we could do viewers here, and I guess we could do viewers dot reserve viewer number. Okay, and we'll do it this way instead. And not that this really affects that much, but I guess it'd be useful. See, the only problem with this is that, yeah, let's just do it the other way. Sorry about that. Yeah, this should be okay. It doesn't really, in the end, matter how we do it. I just think this way will be a little bit better for this particular case. And of course, we can debate this. It's fine. So what are we going to do? Basically, guys, what we have to do is create 10 random videos that these guys have seen based on the viewer number, or the number of videos that we put in. So let's go ahead and do that. We are going to say, also, should these guys be allowed to watch the same video twice? I think they should. I think that should be fair enough. Like, in their latest 10 videos that they watch, it should be okay that they watch the same video again. Okay, so what are we going to do then? Let's go ahead and do it. So for int I equals 0. Oh, j. Sorry about that. J equals 0. J less than 10. Then we're going to do j plus plus. Oh, that was not a plus plus. That was a face of some sort. Okay, so what are we going to do? Let me go ahead and put a comment in here. Defining, 1 second, videos seen for each person. Okay, and let's see, video scene up there. So what we haven't done yet is initialize the video scene. Does seeing the same video affect the affinity? Let me think. Yeah, I guess because I've defined the affinity as a delta function of some sort. Let me go ahead and put this up in notes again. This is actually a good point. So let me go down here and let me say, now viewers may watch the same videos over again. Check affinity. Okay. So that means for each of these guys, we are going to initialize a random number between 1 and number of videos. So this is going to give them a random ID. And then what we're going to do with that random ID is we're going to put it into their video scene vector of ints, and that should be okay. So let's go here. And actually, guys, what I'm going to do is I'm going to define a global up here. I realize a lot of people don't like globals, but that's okay. Define videos scene. Nah, it's okay. We'll leave it this way. This way's probably a little bit better. Okay, so we'll do j to 10. It's, I guess, a little obvious that I didn't prepare this as well as I could have. Anyway, so we're going to do j equals 0, j to 10. Now, what are we going to want to do at this point? We are going to want to basically create the random integer. It's not we don't like it. Okay, so now what I want to do. We have this here, and I'm going to... yeah, it's not encouraged, but there are certainly certain situations where I would say a global is useful. For example, in physics, if you're always going to use the parameter h bar, I would definitely say it's useful to put h bar in as a global, you know? And little things like this, so constants and things like that, I think are quite useful. Unless you want to continually read in a class that is, like, has all these constants in it. But in some sense, that becomes a little bit cumbersome. Okay, so what are we going to do? Let's go ahead and define our integer here. So let's go up here and let's say we have the random video, but I guess what we should do instead is the following. So up here, we go ahead and define the vector that we're working with. So we're going to say viewer of I dot, let's see, video scene dot reserve, maybe. And we'll say 10. Now we'll go down here and let's go ahead and define an integer up here. Int history equals 10. Let's change this to history. Change this to history. Okay, so we'll reserve that. Now we'll just go down here and we'll say viewers of I dot video scene dot pushback, and then we're just going to push back a random number and we'll go from there. And the random number, of course, is done basically as we always do random numbers, something like this. So it should be chosen videos. I guess I always put a distribution at the end, don't I? Let's go ahead and go up here, chosen videos distribution. Go down here, distribution. Okay, and this is going to be, let me see, I guess of generator. And I think that should be okay. So let me go ahead and right and quit this. And let me go ahead and run the last G++ and see what happens. Okay, it seemed to run okay, which means I haven't at least done anything syntactically wrong. So now we have to do one more thing, which is find the affinities for everyone in our vector of viewers. Semicolon after 10. Yep, okay, so that was weird that I compiled then. Okay, see, now it doesn't compile. Chosen video. Okay, good. It's weird that it just compiled. Oh, maybe I forgot to write it? Yeah, it could have been that. I could have forgotten to write it. Okay, so now we have to find all the affinities. So this is going to be defining video scene for each person. Let's go ahead and put this up here. Videos seen by each person. And then we're going to hop down here and we're going to define all the affinities. Okay, so let me go up here and let's go ahead and do this. Why do I always say go ahead? I should stop saying that. Function to find affinity with all other people. Sure. Okay, so we'll do the following. So what are we going to want? We're going to want a double, I suppose, for the affinity. No. Take care, man. Are you heading out? If you are, see you around. Thanks for popping in. Okay, so we need to find the affinity with all other people. Okay. So function to find the affinity. Any reason you don't use or show line numbers? I mean, I can if I want, right? Set number. Set no number. It's fine. I will put it up if I want. It's easier without it. So, okay. So find the affinity with all other people. Let me see. Plus, I only have a finite amount of space to work with. So, setting the line number... Sorry about that. Setting the line number makes it a little bit harder to follow, in my opinion. I tried it once with all of it on screen. It was a little bit hard. Okay, so we'll do find the affinity with all of the people. Gosh darn it, I just got some water. Okay, good. So find affinity with all the people. So I guess we'll do the following. I think it can be void. Yeah, it can be void, I think. And I suppose we'll say void find affinity. And what do we need to return? How about this? How about we return an STD vector of doubles, and we'll say this is find affinity, and we're going to say an individual viewer, so we will say viewer individual, and then I guess we'll say STD vector of viewers, and we'll say viewers, I suppose, or something like this. I guess we could call it group. That would also do. Yeah, group should work. Let's call it viewers just to keep notation. I can change it later. Okay, so now we'll have to find affinity viewer individual, STD viewers viewer. I spelled affinity with 3 F's. Okay, let me see. What else do I want? Yeah, this should be okay. So we have the list of all the other viewers. And it should be dependent on the videos that they've seen. So it should be good. Okay, so let's go ahead and find these affinities. And then I think we'll be pretty close to finishing for the day, honestly. We don't have so much left to do. I mean, I know I've been kind of dragging my feet, but, you know, this should take a few days to get done, I think. So let's go ahead and do it. Okay, so first we need to basically define what the affinity is. The affinity, as stated before, is the number of videos we've seen in common over total number of videos seen. So basically we need a way to find the total number of videos we have all seen together. Now, one more thing we have to do, which is going to be a little bit of a pain, but this should be okay, is basically allocate. Let me see, how do I put this? Oh, this is actually going to be a pain, isn't it? So we have a vector double of all the affinities. And if we assume... let me think. Okay, so let's find all the affinities first, and then we'll worry about ordering them in just a second. Yeah, we can do it that way. It's just a sort command, right? But the issue with that is even if it is just a sort command... Okay, we'll have to think about this in just a second. Let's go ahead and find the affinities first, and then we'll go back to finding everything else from there. Sorry, one of my papers just flew away because of the air conditioner. Also, it's 6 o'clock in the morning and it's still dark. Okay, so let's do it. Find the affinities. Searching through all the other people to find videos in common. Misspelled searching. Okay. For int I equals 0. I less than, let's say, viewers.size. And then we'll do I++. Okay, so now what are we going to do? Let's go through. And let's go ahead and create the STD vector of affinities. So we're going to do STD vector. Vector of affinities. So this is going to be double. Okay. Good. And up here I'm going to redefine affinity to affinities. And this too, I guess. I suppose it's maybe a little bit easier to follow. And let's add a couple spaces there. Okay. So So if for int I equals 0, I less than viewers.size, I plus plus. So now we just have to search through their history and see which videos we've seen together. So every time we've seen a video together, basically we set the delta parameter to 1, and then we go from there. So let's go ahead and say affinity. So we'll say viewer, individual, dot, let's say affinities of, let's say I. There we go, that should do it. It's going to be equal to, what? What do we want it equal to? I guess it's going to be number of videos in common over the total number of videos I've seen, right? So this should be, 1 second, it should be, videos seen. How about shared over total, where total is going to be equal to individual dot video history, videos seen, I think is what I called it, dot size. This should be okay. And then we have to find that shared. So what I'm going to do is I'm going to say if. So then I guess there is someone who has 100% affinity, and that should be okay. Yeah. Maybe instead of reading in a viewer individual, we should read in an int individual. Yeah, maybe that's a better way to do it. Yeah, so let's read in the int. Int individual. Let's go up here, read in the int up here. Gosh, I'm exhausted today. Yeah, we'll see how far we get, and then we'll go from there. So let's say if individual is not equal to, let's say I, then we do this. There we go. DD up here. Now what do I want to do? If individual is not equal to I, then we do this. What else do we need to do? We also need to find the shared number. So let's go up here and define shared. Int shared. Yeah, there we go. Now we have to find shared. And I guess what we do is we go through and we basically just check. Now there's probably a super efficient way to do this, but I'm not thinking of it right now, so let's do it this way. For int I equals 0, and instead of calling this individual.affinities, I suppose we need to call this viewers of individual dot affinities is equal to shared. Then we divide it by individual, so I guess it's gonna have to be, crap. So let's pop it down here. Okay, so it's gonna be viewers of individual, then dot videos seen dot size. Okay, so now we're gonna say for int I equals 0, I less than viewers of individual. Then we want dot video seen dot size. So then we basically have to do not I plus plus. We actually have all of these numbers, don't we? So let's do it a different way then. For here, and let's pop down here. Okay, so what I'm going to say is, let me think. So we have all of the numbers, right? So each individual number, and then all we have to do is check. Yeah, okay, this makes sense. So then we'll do change this to J, change this to J, and then we go down here and do J++. Okay, now we pop down here. Okay, and what we'll do, and actually I think I am going to change the notation here. Instead of doing J++, I want to do the following. Here. And I'm going to say for auto, I guess we'll say video in these guys and change an ampersand in here. Okay, so now what do I want to do? I'm going to say, let me think. Oh shoot, I probably needed the J's. I bet you I did. Yeah, I needed the J's. Dagnabbit. Okay, so let's say int j equals 0, j less than viewers individual viewers scene, video scene dot size, and then we do j++, and then we go down here. Good. Okay, so now what are we gonna do? Basically, what we need to do is we need to say, oh, we're gonna have 2 loops. We might need 2 loops. 1 second. Yeah, I guess we do need 2 loops. Let me think. Is there a better way to do this? There's probably definitely a better way to do this. Let me think. So basically the idea here is that every individual watch, like, let's say video 1, 10, 7, and 8, or something like that. Okay? So he'll watch all those videos. After watching all those videos, what happens next? We then check, has the next person seen video 1? Has the next person seen video 10? Has the next person seen video 8 or whatever? And then we add all those numbers together for some sort of total number shared between the two. And then we find all the affinities from there. Okay, so now the question. What is, hey, H226, what is up? So then the question is, how's the best way to do this? So we can't go through like this. I think this should be okay. Yeah, I guess this is the best way to do it. So we'll do for int k equals 0. Then we'll do k less than viewers of I dot video scene dot size, and then we'll do k++. Yeah, okay, this is fine. So now let's say if we'll set shared equals 0. Just waiting on a buddy to stop up for a while. Figured I'd pop in to see how everything's going, toss an alert. That seems fine. Everything's going okay, I think. However, chat's been super quiet today. Fair enough, since I was gone this past week, right? So it's kind of hard to pop in and pop out so frequently. In fact, not only was I gone this past week, but the week before, on that Thursday and Friday, I was super duper busy preparing for the conference I was going to be going to in China that I ended up not being able to stream those days anyway. So it ended up being that I've missed almost a week and a half, actually. And I have to apologize for that. There really isn't much I could have done in that situation, because I was getting to bed at like 11 or 12 at night, and I need to learn that if I go to bed at 11 or 12, I'm not getting up at 4:30 or 5 to do the stream. That's what I need to learn. But I just, I have a lot of trouble with that. Okay, so we're going to say if, and what do I want to do? I guess I'm going to say viewers. What was that? Individual. What do I want? Dot video scene of j equals viewers of I. Yep, dot video scene of k. Then we share it. We're gonna say shared plus plus. There we go. Now down here we basically say is equal to shared divided by viewers here, and so I'm gonna call this a double, and I think I need to call this one a double too. Good. Okay, so what does this mean? This means that we should be going through. These loops are kind of annoying. I suppose I could have done it in a different way. Let me think. Yeah, I guess I could have had... Yeah, I definitely could have. So let me go down here and let me reset. Down here, shared equals 0. Oh wait, no, that doesn't make any sense, does it? No, it does. shared with an E. Okay, so what are we doing here? Basically, we're searching through all the other viewers to find the videos in common. So the idea is we go through all the viewers that are left. We first check to make sure that the individual that we're working on, so like the viewer we're checking against, is not the individual that we are on, okay? Then, let me go ahead and put an else statement in here. Else. And I'm just going to say affinity is equal to 0 here. So we're going to say viewers of individual dot affinities of I is going to be equal to 0 because it is the same person. Okay, so first we check to make sure that we're not on the individual that we are currently checking for. So like we have some individual, let's call him number 72, and then we check against all the other guys, right? So we have individual number 72, and if I is equal to 72, we don't check that one because we don't care about 72. He's a jerk. So then we go through, and with each of these guys, they all have a history of videos that they've seen, and the affinity is going to be equal to the number of videos shared over the total number of videos seen, right? So the idea then is that we find how many videos they have in common. So I went through all the videos seen by the individual that we're checking, let's say again number 72, and then we go through and we check against all other viewers, right? Videos seen. So we check against the other guy's videos. And basically, if they have a number that is seen between them, then they're good to go. Now, this loop can definitely be optimized, and I'm going to go ahead and put that down. 1 second. Naive method to find all videos shared between two folks. Okay. And that can definitely be optimized, but that's okay. Okay, then after this, we just have to return affinities. And that should be okay. Let's go over here. Let's run G++. It seemed to run. Yeah, okay, that's fine. Wasn't expecting that. So now we have to define all the initial affinities, and this is simply going to be the following. So we're going to say for int I equals 0. I less than, what are we going to say? I guess we're going to say viewer number. And up here, I guess we can do viewer number 2 because they should be the same size. Good. And then we're going to do I++. Good. Okay. And again, guys, if you have any questions, comments, concerns, feel free to let me know. And I'll totally I will totally answer those as soon as I see them in chat. Again, guys, I'm a little bit out of it today. It's been a week since my last stream, so forgive me if it's a little bit dull today. I don't mean for that to be the case, but that's how it goes sometimes. Okay, so what are we going to do? We're going to go through all the viewer numbers, and then what do I want to do from here? I want to individual.affinities double shared viewers individual. Okay, so that seems to work. So now we're going to say, oh, I know what I want to do. We're going to say viewers of I.affinities is going to be equal to find of, what do we want? I suppose we want I, and then we want viewers. Okay, now I forgot a lot of ampersands, and we'll go from there. You would type in your first for loop for init viewers. Do I? Where is it? For int I equals 0, I less than... I'll take a look at that in just a second. Viewers... Oh, thanks. Viewer num. There we go. Appreciate that. Okay. So now we should have all the affinities defined. And now let me do a couple quick things real quick. Let me go through and change this to an ampersand viewers. Saves just a little bit, but hey, a little bit can mean a lot in the end. And we'll put an ampersand here under viewers. Okay, so now we're ready to test this guy under main. So we have these guys set. All we have to do is initialize the viewers and check to see what they are. So let's do it. So we're going to now create an std vector viewers, and we're going to call it viewers. I really need to change that name, but that's okay. Now we're going to say viewers is going to be equal to init viewers. And what do we want? I guess we're going to want a viewer number, and let's just call that 100. And number of videos, we're going to call, let's say, Let's say 10. There are only 10 videos on YouTube right now. Okay, so now what are we gonna do? We're gonna say for int I equals 0, I less than viewers dot size, I plus plus. Okay, now what do we want to do? STT, cout. I guess we're gonna say viewers of I, and then what do we want? I'm gonna want, I guess just to make sure that they're all initialized, I will check to make sure that we have an affinity for each of these guys, and video scene. So I'll check both of those guys. So video scene of 0. So I'll just check their first element and tab and move down to the next line. Viewers of I dot affinities of 0. So again, just checking to make sure that their first element is occupied. And let me run g++. Seems to work. A.out. Segmentation fault. Good. Okay. So let's do g++, and then let's do what is it? FNO emit. No. What is it? It's let me do an ls. Check back to, I think, color quantization makefile. Oop, not ls. I want to do vi. 1 second. Vi. F sanitize equals address. That's the one I want. So let's grab this one. G++. Grab that. Okay, now let's do an A.out. Okay, so let's see, what does it say? In find affinities, what do we have here? Address sanitizer could not provide more info. In find affinities, let me see, init viewers, int, in main. Okay, so it should be in find affinities then. So let's go down here. Okay, so somewhere here we grabbed an element that we were not allowed to grab. It's super dark outside, which recently I found out that twilight is both the early morning and late night. So I guess it's twilight outside, dawn in particular. But yeah, there are a couple crows outside. It's kind of funny. They're just, maybe not they're crows, maybe they're just blackbirds. I don't know. I don't really know the difference between a blackbird and crow. Maybe you guys know. Let me know. But yeah, they're just kind of sitting there. Okay, so let's see, what do we have here? It's also definitely not bright enough to see outside. Like, I can't turn the camera around to show you guys outside at this point, in case you guys were wondering. Okay, so viewers, individual scene.size. I guess we'll just go through and output I and see how far we get. std, cout, I, end line. 1 second, g++, A.out. Okay, we got to 0. Which means in find affinities, let's see, what do we have here? Viewers of 0. Is there something that I did wrong here? Let me think. And I think we're only getting to 0 here too. So let me check up here and let me add a quick statement. We're gonna say affinities found, I suppose. No, we are not even finding the first affinity. So it's definitely in this naive method to find all the affinities. It has to be there, right? Okay, so int j equals 0, j less than viewers, individual viewer scenes.size. Should be okay, k. So let's just output j and k too. I mean, I could use GDB. Yeah, that's fine. I could, but it's easier to do it this way right now. I, tab, j, tab, okay. I also always forget how to use GDB. It's like, I know it's super simple, but I always forget. Let's write this, go up here. G++, edit out. Okay. Interesting. Okay, so let me see. I can try to run in GDB, but again, I just literally always forget how to run GDB. So let me run it, what is it, with the -g command, I believe. And then we'll run GDB. A dot out. Okay, we run this. Now let me see. Vector of length 100, capacity equals 100. And find affinities. Let me see. Vector of length 100. 103? Oh, it's down here. That wasn't what I was expecting. Viewers of individual. Yeah, let me go ahead and quit here. Yes. Let me go up here. And let me see something. So, I want to... Yeah, I mean, I just did that. 1 second. I want to print out a couple things so that I know what's happening. So let me go up here. Let me see. So I want to print out I here. 1 second. Affinities of I equals 0. So I. And then end line. Let's go to G++. A dot out. So this one only gets to 0. So that bug that we just saw up here doesn't make any sense. Because it says vector of length 100, capacity equals 100. Capacity 100 equals... Oh, maybe this means something different. Let me see. Viewers. Let me try it one more time. Run. Let's do print individual. Yep, that's what I thought. I guess we print I. Is it also equal to 0? I guess, can we print viewers? Let me see. That didn't really help, did it? Nope, that's not helping at all. Let's go up. What do we have? There's probably like a dot 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 or something in there. Let me see. Vector of length 10, capacity is 2. Yeah, so these guys have them all initialized at random. That's good. Hey, Husky, what's up? Unfortunately, I'm not working on HTML today. Let me see. So, vector of length 0. Okay, affinities. Where do we have the affinities? Let me see. Individual? Oh, you know what I might not have done? Affinities of I. Maybe what I forgot to do. Let me go up here. Yes, that's probably what I forgot to do. Yep. Let me go up here and let's go ahead and create a double affinity. Here. And then down here I'm going to say affinity is equal to this. And user.affinities, let's say dot pushback. 1 second. This should do it. And I'm going to put a dot here. And then what I want to do is put an affinity here. Is going to be equal to double shared. And then we're going to divide this by this nasty guy right there. Dagnabbit. I'm always tired too. Today I'm especially like doubly tired. Not double as in the type, but double as in I'm super tired because, you know, China last week and stuff. So let's see, what do we have? Write this, go over here, Control D. Yes. Let's go ahead and run G++. Now let's run a.out. Oh, it still broke. Interesting. I didn't expect that to happen. Affinity is equal to this. Oh, I know why. I forgot. Let me see. Affinity should be equal to the number of viewers, right? So up here, what we need to do is while we reserve the history, we should also go down viewers. Let me see. Of I dot affinities. And I want to do reserve of the following. So I guess we're going to say viewer number. Now let's do G++, a.out. Okay, that one still broke. I have to figure out what to write my thesis on within a month. I'm terribly sorry. What exactly are you studying again? I totally forgot. I know that some of my friends have just finished writing their thesis. In fact, 4 of my friends are literally either in the process or finishing up their thesis right now as we speak. Well, not as we speak, because it's 6:30 in the morning and they're probably sleeping. But, you know, same thing. Like, they're all working on their theses. Okay. So, we've reserved them. Engineering IT. Oh, cool. So, let me go over here. Let me run GDB. One more time. Let's run that. Now, let's see what happens. It is viral video CPP line 42. So it's currently... Oh, it's not liking this one. Huh. Source file is more recent than executable. Let me just print. Read about petting ducks. Viewers. Okay, let's see. What do we have here? We have affinities equals SD vector of length 0. Oh, the affinities are still not set. Capacity 0. Okay, so let's see. What did we do wrong then? Q. Let's control D. Yes. Okay, let's see what we have. We have viewers at reserve, but we should be reserving viewer number. But for some reason it's not. I less than viewer number. So for every viewer, we should be reserving an affinity here, but I suppose that's not quite working, is it? So let's go down here. And let's see, viewers.size. Let's do this. So let's do affinities. 1 second. Viewers of i.affinity.reserve. And let's do viewers dot size. Let's try this. 1 second. G++. A.out. Okay, so this one seemed to do something at least. Let's go through and see what we have. So it's still breaking at a certain point. Let me see. Information analytics is the direction we're taking. Let me see. Information analytics. What does that mean? Information analytics. So let me think. I mean, obviously, you know what you need to write your thesis about, right? I mean, this is not... let me see. What are we printing out here? We're printing out all these guys. And then it breaks at the very end. Why would it break at the very end? Not quite sure here. Return viewers. Return affinities. Why is it breaking? Let's run GDB. Let's run this. Okay, returned a seg fault at line 42, which is a little bit weird. Here's that size. Let me go ahead and run I suppose. Oh, sorry. Quit. Let's do print I, not IT, I, 99. Yeah, okay, fair enough. Big data is one thing I just, I have trouble touching. You know, like, it doesn't come about in computational, well, okay. It does come about in computational physics a lot. Like, you run into situations where, like, I don't know, you've got hundreds of gigabytes of data, terabytes of data, constantly being churned through by people, for example, in, like, colliders of sorts and stuff. But, yeah. Okay, so let me run this one more time. Yes. And let's see. It says line 42. This is where we're having the issue. So why would we be having the issue here? Because it looks to me like viewers of 99 should totally have something. So I listen to viewers.size, I++, viewers.size. Yeah, we should totally have something. But for some reason we don't. Okay, so let's see. Let me just go ahead and print out I here too. std, cout I. Let's go ahead and control D. Yes. And let's run G++ one more time. A.out. Okay, let's see what we have. So this guy does go up to 99. So we should have all of these guys being initialized just fine. However, it is a little bit weird that they all have the same affinity. That's a little bit weird. So that's something we have to kind of look into. But yeah, there's a lot of things we have to look into. I'm not sure exactly why this guy is seg faulting. So it says it's seg faulting on line 42. But again, it doesn't seem like there's anything wrong with 42. Because 42 is just outputting the affinities. Unless there is no affinity for that guy. But we clearly do get to 99, right? So we did just check. We go to 99. For some reason, that last guy is just not being initialized correctly. So let's see, what do we have here? Return viewers, affinities. Let me see. Is there something wrong with this guy? Viewer number. I equals 0. I guess maybe we gotta put this. std, cout. Let's do I and line. Go to G++, add it out. Okay, let's see, what do we have here? That one goes to 99. This one goes to 99. They both go to 99. 97, 96, 95, 94. Wait, let me think. Viewer number. Which one is going to where? 1 second, I gotta think about this. SEC out, there is one of them. See, if we go up way up here, it's only going to 76 up there. Let's go to G++ one more time. Hit it out. Oh, I see what's happening. This is 99, 99, 99. Okay, so I see exactly what's happening then. Okay, sure, that's fair enough. So let's go ahead and remove this. Write this, go to G++, add it out. And now we should have 99, 99, 98, but the one above it is 99, so this should be okay. Okay, so let's see if we can figure this out before the end of the stream, and then hopefully, hopefully we'll be good to go for tomorrow. So what do we have here? STC out I, let's see, new line. This is clearly not a problem. The only problem that I'm running into is down here. So let's also output I there, and let's see what happens. Let's go here, let's do I. Tab. Let's try it again, G++. Add it out. Okay, this one goes up to 98, and the 99th has the seg fault. But it doesn't look like we're missing anything. Yeah, it looks like we still have 0 to 99. Yeah, it should be from 0 to 99. But for some reason, that very last number is a seg fault. Which says to me it's just not being initialized, but it's clearly being initialized. And it's only the affinities that's not being initialized. It looks to me like the... Let's do viewers.size -1. G++, add it out. Yeah, so that one runs just fine. So, what did I do wrong? Did I have -1 somewhere in here? The find affinities. Reserve viewers.size. Okay, seems good to me. SDC out I less than N. We are clearly going through everything. We clearly set the affinities. Okay. Let me see, individual not equal to I. Then we have our naive method to find all the affinities, which could be wrong, for all I know. We'll look into that again in just a bit. So the affinity is going to be equal to this, and then we push back the affinity. Okay, so on individual number 99, what happens? Viewers of all of the other guys, let me see, I.affinities.reserve, viewers.size, should be okay. Oh, wait a minute, I think I did something stupid here. Yeah, I definitely did something stupid here. Let me go up here. And let me do it this way. Viewers of individual dot affinities dot reserve. This guy right here. Now let's go over here to G++. Add it out. Okay. Still broke. But this time at a different spot. So that's nice. Let me see. No, it still says 42. Never mind. Still broke at 42. G++. Add it out. Yep, totally broke there. Well, that's a pain. Let's run GDB again. Let's do run. And now let's do, I guess, print viewers. See what we got. So let's see. We have affinities, SC vector of length 0, capacity 0. Okay, so for some reason these are not being initialized correctly. Okay, so let's see what we have. Return affinities. Viewers of I.affinities is equal to find affinities. Is it because I didn't reserve it up here? Maybe that's the issue. So I guess we do viewers.i dot, 1 second, of I dot affinities dot reserve, and let's do viewers dot size. Now let's try this. Quit. Control D. Yes. Now let's try a dot out. Oops, sorry. G++. A dot out. Okay. Still breaking at the same spot. Okay. So question is, we have the vector. We're returning the affinities at the end. Let's just do it this way. This is a little bit easier. I don't know why it's not. Whatever, this is okay. So we'll say viewers.size. Okay, and then we go down here, we're just gonna say viewers of wait a minute. Oh shoot, I think this whole thing is written incorrectly. Affinity equal double shared. Let's say viewers of individual dot affinities of, let's say, I is going to be equal to affinity. Okay, so what are we doing here? We don't have to reserve it up here, I don't think. We can remove this guy. Okay, so we're setting affinities equal to viewers.size. Then we're going through all of the viewers, and we're saying SEC of I should be okay. Individual not equal to I. Affinity equals that. Okay, let's try this one. Go over here, G++. Of course, this has an issue. Viewers.size. 1 second. Here we are here. Grumble, grumble. Ain't it out? Okay, this one broke much faster. Dagnabbit. Okay, what is happening here? Let's run it again in GDB. It's not really going to help any, though. Doesn't help at all. Find affinities I and viewers. There's something I'm clearly doing wrong here. Okay. So this should return an and it's a vector of doubles, which the affinity should be. And we're saying viewers of I dot affinities is equal to find affinities of I and viewer. Okay, that should be okay. So we go ahead and initialize affinities, and we return affinities at the end. We go through all the viewers, and if the individual that we're working with is the same as I, then it's set equal to 0. Otherwise, we go through and we say, let me see. Oh, that's interesting that it's breaking on the first one. Because the first one we're just going down here. Viewers of individual. Let me see. Viewers of individual dot affinities I equals 0. So we should just be setting the affinity equals 0 for the first one. Let me try something. Go over here, G++. Else, of course, doesn't exist. G++. Get it out. Okay, still breaking in the first one, but this one definitely shouldn't break. Okay, this is just setting all the affinities equal to 0, right? So we set all the affinities. We say vector double of affinities, viewers.size, okay? So that's the guy we're returning. Then we create a double affinity. We go through. Oh, what am I doing here? Well, let's do this. Affinities of I equals 0. Let's do G++. A dot out. Okay, that one seemed to work. Let's go up here. We're returning the affinity. So we want this guy to be that. G++, A dot out. Okay, there we go. That took significantly longer than it should have been, just because I was super exhausted, and that was silly. Okay, but that's okay. That's okay. It's fine. So they've all seen 10 videos. The only problem I have here is that some of these affinities are higher than 1. Is that okay? Let me think. Double shared. Let me see. The affinity is equal to the number of videos seen in common over total number of videos seen. So what does that mean if the affinity is higher than 1? Well, that means the shared value must be higher than 10. I think. Yeah, so how would the shared value be higher than 10? Let me see. If viewers individual... Let me think. For j equals 0, j less than viewers individual dot video scene dot size j plus plus. For int k equals 0, k less than viewers I video scene dot size k plus plus. If viewers of individual dot video scene of j is equal to viewers of I video scene k shared plus plus. Let me see. How would this be higher than 10? I suppose we're going through all of the people, aren't we? 1 second. Viewers of I. Okay, so we're going through all the people. We're checking all of their videos seen. What I want to do then is I want to output shared here. Let's do std, cout, shared value is the following new line. Go here, g++, a dot out. So we got the shared value is, yes, so some of these are clearly above 10. In fact, a lot of them are. Okay, so let's see. What does that mean? That means that we could be double counting, maybe, but that doesn't make sense that some of these are odd. Okay, so let's see, dd. Okay, so they're clearly all above 10. For int j equals 0, j less than viewers of individual dot video scene dot size. That should be 10 videos seen. So we should be just going through 20 different videos. Just to be safe, let me just go ahead and output that too. So std cout. That was a sout. J plus k is j plus k. 1 second. New line. Right here. And let's go to g++. Get it out. Okay, so it looks like 18 is the highest these guys go to, which is fair enough. That's 9 plus 9. Okay. Yeah, that should be okay. Yeah. I think. Maybe it should be going to 19? But let's see, how do these guys go there? Duplicate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, guess let's go ahead and dd here. Let's see, videos individual scene.size j. Wait, let me think. Maybe this shouldn't be k less than viewers. Maybe this should be k equals j. Now let's try this. G++. A dot out. Yeah, that did it. Good. They should all be... Oh, except for that one. That's a 1.1. Dagnabbit. That should not be above 1. Darn. Okay. So except for that one, which is a 1.1, the rest are all set. So let's see, how are they all set? What are we even outputting here? 4, 2... Oh, wait. Zero's affinity with itself is 0. That's good. What's this guy? This guy is 31. So this is saying that person 31's affinity with 0 is 1.1. So that means we're still overcounting somehow. So let's check this out. Then let's output k plus j again. So let's do std, cout, j plus k is the following. New line. Let's go over here and let's run, 1 second, g++, a dot out. And let's go up to these guys. So it looks like these guys go up to 18, and it should be, let's see, what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 2, 3, 4, 5, 6, 7, 8, 9. Okay, yeah, so we're clearly counting something silly here. What do we actually need to count? Let me think. We actually need to count. We should only need to count 20 times, right? So we check 1 against 10, 2 against... it should be 2 against 9. So we're checking... Oh, wait. We have to check the first number against... You know what? Is there a find thing? There might be a find in C++. Let's do that. Find vector C++. Find. Let's see what we got here. We'll just go down here to find. Okay. Using std find. What do we want? Iterator find 30. If... Yeah, okay, so this is kind of what I want then. Yeah, okay. Let's just use this for now. Because why not? Yep, this should be okay. Let's just do that. So let's go ahead and remove these guys and go from there. So let me go ahead and comment this guy out. Whatever. So we're going to say for if, what do we want here? What did they do here? They said iterator. And how do they define iterator? Vector int iterator it. Let's do that. Let's go std vector int iterator it. And then we're going to say it. It's going to be equal to, and I guess we're going to want viewers of i.find. This should be okay. Yeah, I'm just gonna use find. Should be a little bit easier. And I guess we're just gonna go search through the entire character and then look for, yep, so that's what I want. So we're gonna want viewers of i dot, and it's not gonna be viewers of i dot find, it should be viewers of i dot video scene dot find, I believe. 1 second, let me check. Equals find. Oh, oops, I'm doing it wrong. Iterator equals find. Viewers of i dot videos scene dot begin. Then let's see, viewers of i dot video scene dot end. Pop this down here. And then what we're looking for is viewers of individual dot videos scene of j. Okay, so we're gonna do this, and then we're gonna say if let's do it is not equal to, what did they say? I believe they said viewers of i dot video scene dot end, something like this. 1 second. Not equal to, yep, that should be okay. We do this, and then we say else. But I don't think we need an else in this case. Yeah, I think this should be okay. So I think we should just be able to do the following. Shared plus plus. Okay, let's go over here. Let's run a G++, see where I broke it. Shared, let's go here. It's wrong. Else, without a previous if. Let me see. For, that should have a previous if. 1 second. If individuals. Oh, maybe I need to bring this down one more line. Do G++. What did I do wrong? No matching call for function std vector. Find. 1 second. Iterator. In vector double find affinities. Int viewer ampersand. Let me see. No matching function call for find std vector iterator, std vector iterators. That should be an int. Let me see. Viewers, video scene, j. 1 second. That should totally be an int. What happens if I just do... What happens if I just change this to definitely an int? What happens then? G++. Yeah, so it still broke. My question is why? No matching function call for find std int iterator. Okay, let's see what do we have here. If iteration not equal to vector end, I'm before that. Let's see. Iterator equals find. My vector. Oh, I forgot algorithm, I bet. That could be it. Go up here. G++. There we go. That one made it. Yep. That was it. Okay, so let's go down here. No, you're good. You're good. Thanks. So let's go down here. Remove this. Go up here. Remove that. Right this. Go to G++. A.out. And let's see what we got. It looks like the highest any of these guys go is 1. So this looks like it worked. Let's go ahead and remove these guys down here. Okay, and with that, guys, I'm going to go ahead and call it for today. So let me go ahead and do an ls. Let's see, viralvideo.cpp. Let's do a git commit. First, let me go into here. Vi viral video, cpp. And let me add a quick compile instruction because I don't have a make file yet. Compile with. And I think it's just standard G++. Viral video.cpp. And there we go. Should be right. So let's do a git commit viral video.cpp message. Okay, that's not what I wanted. Adding a simple skeleton for our viral video. And what do I want? I guess it's gonna be viral video epidemic algorithm. Okay. So now we're gonna do, yes, of course I didn't. Git add. 1 second, viral video.cpp. Now let's do git commit. Okay, 116 insertions, not bad. So let's do git push origin master. And now you guys should have access to it online about now-ish. So feel free to check that out online. We got a good bit done today, even though I was a little bit exhausted. I think tomorrow I should be a little bit more peppy. Sorry about that. I super tired after, I don't know, I've been having trouble getting up in the morning, so I figure getting up regularly from now on should definitely help that. Outside of that, guys, I would like to thank you so much for coming in today. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simulaos when we finish up, well, not finish up, but we continue our epidemic algorithm. I think we'll get to YouTube side tomorrow. And then I think by maybe Wednesday, Thursday, or Friday, I think by the end of this week, we should be done with this simulation. I don't see any reason why it would take longer than that. That said, I don't know. We'll see how long it goes. And of course, guys, if you have suggestions, please feel free to let me know, and I will do my best to approach those suggestions as I see them. Anyway, guys, thanks again for coming in, and I will see you next time. Bye, guys.